Alright guys, so let's review 5.2 and 5.4. 5.2 has the Euler method, which is a method to solve differential equation of order 1, initial value problem. So if the differential equation is given dy by dt is equal to f of ty, and this is the initial condition, right? This is the first order differential equation, and this is the initial condition. Alright, this is the interval which is given on which we need to find the solution. Okay, so see, at the initial point a we are getting a initial condition. So what does Euler methods do? This is given on page 110. Let me show you. See here, this is the Euler's method, you see, on page 110. Equation 5.2. During the lecture I did this example, so now I picked an exercise question from exercise 5.2. I think it's page 266. This is given on page 266. So what Euler's method does is it approximates your, see, what is the solution? You see, the solution of this differential equation is y at t, right? But because we are approximating, so what we do, we approximate it at different points at ti. So this is approximated by wi. Because y is for exact solution, so we call w for approximate solution. This is exact solution on the left, and this is approximate solution on the right. Okay, approximation wi. So basically what we do, we are from a to b, right? So we first see how many your h will be given. Whatever h is given, it's given, right? So what we do, we start with a plus h. So this will be your t1, t2, t3, so on up to tn. Okay, so b will be tn, a will be t naught, the first one. So at somewhere here it's ti, the general ti, right? So at this point, if this is your function y, then this is your exact solution, but my wi can be over here or here. You see, wi can be different, right? Because it is an approximation, it can be somewhere here or here. So this will be your wi, right? So this point, blue point, is exact solution, which is y at ti. So y at ti, but we hope that they are very close to each other, right? So first of all, if h is given, you will find ti by a plus ih. You see, if I add 1, t1 will be a plus 1h. T2 will be a plus 2h. So if I keep on adding, right, 1h, so it gives you t plus ih, and the last one will be a plus nh, which will be equal to b, right? So we can also write it as b minus a by n if you want to find h. This is your ti. After finding ti, the first point, because here my solution is given, y at a is given as alpha. You see, if this is my solution, y at a is given as alpha. If this is your y-axis, this is your alpha, right? So this point is called the first approximation w naught, because w naught is the approximation at t naught, which is the first point a, which is alpha. So you are starting with w naught is equal to alpha, and the next point, which is w1, w2, w3, will come from this equation, that you start with I plus 1. If you have w0, it gives you w1. So wi is equal to the previous one plus h into the function value on the right side at the previous point. See, simple is that, you see. So the h which is given, we will multiply by the right hand side. You see, right hand side is ftwy, but I will calculate it with the previous point tiwi. Then I add the previous approximation, it will give me the next one. So that is I is equal to, for I is equal to 0, 1, 2, so on up to n. So this is your Euler's method. So now if I apply this Euler's method here in this question, this is the a part. Fty is the right hand side, right? So see, y prime is given t e to the power 3t minus 2y, and y at 0 is given as, y at 0 is 0 and h is 0.5, right? And we have to find the solution over the interval from 0 to 1, right? So t is given from 0 to 1. So it means, first of all, because T naught is your 0, which is your A, right? The first point is 0, right? So I will find the next point T1, which will be A plus H, which is 0 plus 0.5. So that is 0.5. So I will keep on adding 0.5 here. So T2 will become T1 plus H. So 0.5 plus H, which is 1. So that's it. I reached the final point. That's it. You see, I reached the final point. So if I started from 0, we reach to 1. So if, let's say, if H is 0.2, then I will take T1 0.2, T2 0.4, T3 0.6, T4 0.8, and T5 will be equal to 1. So I will keep on going unless I get the last point, right? So this is A plus 2H. Or you can also write that T1 plus H. So if you add in the previous point, you can add H to get the next one. So every time you keep on adding H. So this is 1. So now your W naught is the right hand side here. This is your W naught, right? So that is 0. This is the first point. Now W1 will be W naught plus H F of T naught W naught, right? So which is this is your right hand side is your F of Ty. This is F of Ty. If you want, you can put the values here, but anyway, W naught is 0 plus H is 0.5 and F of T naught W naught. What is T naught W naught? T naught is 0, W naught is also 0. So this will give you 0 plus 0.5. F of 0, 0 will give you T0, Y0. So this will remain 0. Okay. So your answer is 0. But now W2 is W1 plus H F of T1 W1. So W1 is 0 plus H is 0.5. F of T1 W1, T1 is 0, T1 is 0.5, right? So this is T0.5 e to the power 3t, which is 0.5, and minus 2 W1. So W1 is 0. So this is gone. So you got 0.25 e to the power 1.5. You see, 0.5 into 0.5 is 0.25 and 3 into 0.5 is 1.5. So here you can approximate. So that's it. You just have to go 2 steps. For I is equal to 0, give you 1. For I is equal to 2, it gives you W2. That's it. This is the approximation at Y1. See, if you want to find approximation at Y1, this will be W2. So that is your answer which you got here. Alright. So this is simple Euler method. There is nothing wrong with it. So I think gave you 2 questions for practice in WhatsApp group. So I did one of them. So here you can do 5A. I think I gave you the 5A for the one. The second one is the Ranch-Kata method, which is there are 3 methods in your 5.4, but I only gave you a Ranch-Kata method of order 4. This is your method, which is this is order 4 method. Okay, this is on page 288. On page 288, this method is given. So you have to remember this. That K1 is H F of T I W I. So I will give you this formula, don't worry about that. I will write this Ranch-Kata method of order 4 and you just have to apply the method. So if I write the question which I gave to you as well, it was exercise, you see here. I gave you 13A. 13A means repeat exercise 1 using the Ranch-Kata method of order 4. So exercise 1 is this one. I gave you 1A only, right? This is the same equation, TE3T minus 2Y, exact same solution question which was given. So let me write Ranch-Kata method over there and then we can follow this. So I can do one step and you can do the second step easily. So let me write this 5.4 is Ranch. Some people call it Range Kata method, whatever, but I think Americans call it Ranj, so we can call it Ranch-Kata. I don't know, because it's not an English word. Some Latin or maybe some European mathematician They have strange names. So this is on page 288. So let me write that. Page 288. Simple one method. There are modified Euler method, midpoint method. We are not going through them. You know, there is a MATLAB software for mathematics. Later on, you may be using your MATLAB. MATLAB software uses Runge-Kutta method of order 4 to solve differential equations. So that's why I thought we should go from here. So again, why not is your first point alpha. Now W1 has a very big formula. So instead of that, they split it. That's that instead of going straight to W1, let's find these things. K1 is your h and function value at ti wi. Okay, and then your next 2 points are given at the midpoints. Instead of going to the next point, you see ti plus h will give you the next point ti plus 1, right? If you are at ti, the next point is ti plus 1. So this difference is h. But if I just go halfway up, this is not the next point. This is ti plus h by 2. This does not give you the next point. So this uses the midpoint basically, ti plus h by 2 and half k1. Okay, half k1. Wi plus half k1, sorry. I also go to the next midpoint, but next midpoint comes from wi, because we have wi, calculated wi, plus instead of going to the next, I get this one. So see this k1, which I found this k1 here, we are using this here. Okay, this k1 is here. Then my k3 will use k2. You see, if I write k3, it is again, you see, same formula, h f of ti plus h by 2, see the same formula, but wi plus half k2, because we have already found k1. See here, because we have found k2, so now replace k2 here. Okay, and then k4 uses k3, but they don't use the midpoint. They go to the next point now, you see, ti plus h, which is basically ti plus 1. Okay, so we go to ti plus h, the next point. So next point is ti plus 1. So what we can write? We can write ti plus 1 here instead of I plus h. So this is ti plus 1, the next point, and here we use k3. But you see again, wi not half k3, just k3, because we did not use half here. We did not use half here, so we are not using half here. In first 2 points there is half. In first middle 2 points there is half h by 2, half k by 2. Now once we found all these 4, then your wi plus 1, the next one, because we are going from wi to wi plus 1, right? Because the first one is given. So if I have w0, it will give you w1. When you have w1, it gives you w2. So on, right? So once you have wi, it gives you the next step. So from w2 to w3, w3 to w4. So now I will write the next step, which is wi plus 1 by 6 k1 plus 2 k2 plus 2 k3 and k4. Okay, so see the middle k2 k3 has 2 in it, and k1 k4 are alone. So k1 k4 are alone here. So once you have found 1 2 3 4 values, then replace them here, 1 2 3 4. Okay, so this gives you the next one, and this is true for I is equal to 0 1 2 3 so on, right? So this gives you, because why we start from 0? Because 0 gives you w0. I0 will give you from w0 to w1. Then I1 will give you from w1 to w2 and so on. Alright. So let's repeat this question. Here my wfty was t e to the power 3y. So this is 13th A. Because in 13th question he said repeat 1a, which is y prime is equal to t e to the power 3t minus 2y, and we are finding the values from 0 to 1. Y at 0 is equal to 0 and h is equal to 0.5. So if we change h, of course the ti's will change. So here we know we found ti1 0, t1 is 0.5 and t2 is 0.1. Let's say if I give you h, smaller h, which takes 5-6 steps to reach the end point, I will make it short and make it just 1 or 2 iterations. I can say that do just 1 iteration for Anchkata method. Okay, if you can do 1 iteration, of course you can do 2, 3 as well. So I will not give you more than 2 iterations like this example. It has just 2 iterations, 1 and 2 iterations, only 2 iterations needed. So I also give you the question which has no more than 2 iterations. Okay, so then the first one, W naught is equal to alpha, which is the initial condition, the right hand side. This is your W naught, which is 0. Okay, so W naught is 0. This was your T naught. This was your T naught 0. So that's what I wrote here. Okay, so now I will find K1, right? K1 is H F of T0 W0. At first step, right? The first iteration. In first iteration, my K1 starts from 0, 0 on the right side. I is 0, right? I is equal to 0. So this means H F of T naught is 0 and W naught is also 0. So this will become H is 0.5. F 0, 0 is 0 e to the power 0 minus 2 into 0. So again this remains 0 because 0 into 1 is 0 minus 0. So this remains 0. Now K2 is H F of T naught plus H by 2, right? And W naught plus K1 by 2. Now I will replace this K1, right? K1 0. So I will replace it here. So this will become T naught is 0 plus H by 2 is 0.25 because H is 0.5. So H by 2 is 0.25, right? So 0.25 in 0 plus 0.25 and W naught is also 0 plus K1 by 2 is also 0. Right, K1 is this and K1 by 2 is also 0. So now I have to find the function value at this point, right? The function value at this point, and outside it is H for all. Outside H is H, it's not changing. So H is 0.5. This is T e to the power 3 T minus 2 into 0. W is still 0, right? So you got, let me calculate. So this becomes 0.5 into 0.25, 0.125 into e to the power 3 into 0.75, right? 0.75. So that becomes 0.264625. So you should also write 5-6 decimal at least. Now K3. K3 is H into F. The first point is the same, T naught plus H by 2. But here it is W 0 plus K2 by 2 now, because we have found K2. So I will use this K2 here now. This K2. Okay. So now this will become H F of, this is 0.25, and now K2 by 2. W naught is 0. So 0 plus K2 by 2. So the answer which is still on my calculator, I can divide this by 2. So that is 0.1323, and I will add W naught, but add W naught is 0, so no need. So 1323125. Okay, so now this will become 0.5, 0.25 e to the power 3 into 0.25, 3t minus 2 into y is 0.1323125. Okay, so let's see what that is. Now you can write this as 0.5 into 0.25 into e to the power the 0.75, write it close, minus, or let me 0.5 into 0.25, I erased it, into e to the power 0.75. So the answer is this, minus 0.2646 minus 2 into minus 2 into 0.1323125. So this will be minus. So that becomes 0.00 9, should not be 9. Point 264,625 minus 0.5 into 2 becomes 1, right? 0.5 is 1 by 2 into 2 becomes 1, and minus 0.1323125. So this becomes 0.1323125. So this is your answer for K3. Now I will find K4, which is H into T1, because now I go to T1 and W naught plus K3. So K3 is not divided by half. Okay, and this is T1. So T1 is .5. H f of 0.5, and W naught is still 0 plus K3 is 0.1323125. Okay, so now so H is 0.5, this is 0.5 e to the power 0.5 into 3 minus 2 into 0.1323125. So now you have 0.5 into 0.5 into e to the power 1.5. Like 3 into 0.5 is 1.5. Is this one, and minus 0.1323125. So this is 0.988. 1097. So you can write 11. 98811. Because it is 988109, so you can write this. So now I have the next one, which is W1, which is W naught plus 1 by 6 K1 plus 2 K2 plus 2 K3 plus K4. So this is the next one. So they split this, because if I write everything here, the formula will be very long. So this is the reason we split this into these 4 steps. We found K1, which is 0. Then we found K1. W1 is 0, 1 by 6 K1 is 0 plus 2 into K2. K2 is this, 0.264625 plus 2 K3. K3 is this, 0.1323125 plus K4. K4 is this one, 0.98811. So this is your W1. So this is your one iteration of your method. So I can now multiply 2 into 0.264625 plus 2 into bracket 2 into 0.1323125 bracket plus 0.98811. So you got this one, and divide by 6. The answer divided by 6, 0.2969975. So if you want to make it little simple, you can write 0.2967, right? Because this is 699, so I can round it here. If you keep 0.69975, the whole thing, this is the best thing. Okay, but here I can round it off. So this is your one iteration. So this is the approximation to y. This is equal. This is approximation to y at t1, which is 0.5. So w1 gives you the approximation at y1. Okay. Now I will write y1. So for second iteration will become So you can complete the second iteration. So the video is becoming longer. So second iteration, you will again find K1, K2, K3, K4. But this time K1 will start from T1, W1. Okay. K2 will be H of T1 plus half H, because we go a half step up, and W1 plus K1 by 2. And K3 will be H F of T1 plus half H and W1 plus half K2, and then K4 will become H of F T2. The next step, we start with T1 and these two use midpoint, you see, T1 plus half, but then T2. And here W1 plus K3, because I don't use half here. So after doing this again, using the same method, you will get W2. So you can calculate these things. Of course, you can do one by one. Put K1 here, then put K2 here, then put K3 here. So get this one. So then your W2 will be W1 plus half K1 plus 2K2 plus 2K3. And these are new Ks now, not the old Ks. Okay, so use these Ks here. Use these new answers here. Okay, don't use the previous Ks. They are used now. They are gone. They are already used. They are gone. Okay. So now we calculated new K1, K2, K3, K4, and they will come here. And this will give you the approximation of Y at T2, which is 1. Okay. So we got the approximation at this 2. So I hope you can complete this second iteration. For your practice, it will be very good if you can complete it. Okay. So that's it from 5.2 and 5.4. I hope you understood this one. If you just do this one iteration, I think this will give you enough practice. But I think I gave you one more problem on WhatsApp group. Let me write it again. I gave you 15A, right? I said 13A and 15A. Repeat exercise 3 using Rajkata method. So you can do this one, this 3A. Okay. Draw. So this question I gave you. Okay, so do this one for your practice. If you do one, and the same thing, the same question I gave you from Euler's method as well. Okay, so yes. So here there will be lot of there are 10 iterations. You see here, because H is 0.1. You see, H is 0.1 here, so it means it, and you are starting from 1 to 2. So T naught is 1. So T1 will become 1.1, then 1.2, 1.3, 1.4, up to 1.10, which is 2. So T2 will be T10. So there will be 10 iterations. So I think these are too many iterations. So I suggest you to do 2-3 iterations, maybe 1 or 2 iterations for Ranjkata method, and Euler method you can do the full, because Euler method is not that difficult. So for Euler method you can repeat this, you can do all 10 iterations for your practice, but keep it less, because I will not ask you 10 iterations in your exam. Okay, they are too much. So you can do exercise number 15A. Okay, section 5.4. So that's it. I think let me send this notes and video to you so that you can repeat it. Alright guys, see you. Good luck for the exam.